In this video, we'll look at how to factor and then solve a quartic polynomial when that quartic polynomial has terms missing. So if you look at this polynomial, it's clearly quartic because of its degree of 4, but there are terms missing. It reads x to the power 4 minus 5x squared plus 4. There's no x cubed, and there's no x term. That's okay. We'll use factor theorem as normal, and we'll try picking small integers that work, like let's try x equals 1. 1's going to be a good choice just because of these coefficients here. I have negative 5 and plus 4. If I have that 1 there, you'll see it's a good choice because I'm going to get 1 to the power 4 is 1 minus 5 times 1 squared is just 5 times 1, or 5, plus 4, which equals 0. And that's good because now I know this 0 is from a factor that works, and I can use that 0 for synthetic division. If you don't know how to do synthetic division, check the video on how to do synthetic division. It's called dividing polynomials. There are different videos now on dividing polynomials. Nevertheless, I'll assume you know it. What I'm using is my 0, which is 1, and the coefficients here. But here's the key when there are terms missing. The coefficient of the first thing is a 1, x to the power 4, but there are no x to the power 3, so put a 0. There are negative 5x squareds, so put that next, but there are 0 x's. You have to fill in the spots of the coefficients that are missing. The last constant term is 4, we'll put that in. And now go through your synthetic division as you know it. You've watched those other videos. Bring the 1 down, you get a 1, multiply. 0 plus 1, add. 1 times 1, multiply. Negative 5 plus 1, add. 1 times negative 4, multiply. 0 plus negative 4, add. And then 1 times negative 4, multiply. 4 plus negative 4, add. And we get 0, which means we did it right. We factored. So we have f of x equals, our factor corresponding to 0 of 1 would be x minus 1. And now read this remaining polynomial. These are my remainders, so this is my constant. So that's my x's, my x squared, so that's x cubed, plus x squared, minus 4 x's, minus 4. Now I need to try and factor this. I need to pick another x to try. I already tried x equals 1. It could happen that x equals 1 works again, but it might not. I'm going to try x equals 2. Just see if that works for this polynomial inside here. 2 cubed plus 2 squared minus 4 times 2 minus 4. I picked positive 2 because I already have some negatives, so I think picking positive numbers should work. Let's see, 8 plus 4 minus 8 minus 4. Perfect. You can try that on your calculator, but it's clear to me that's going to equal 0. So it means 2 works, and I'm good to go again on synthetic division, but just on this inside piece. So I'm going to use my 0, which is a 2, and then the coefficients of this inside polynomial, which is a 1, a negative 4, and a negative 4. Synthetic division again. Bring down the 1, multiply. 1 plus 2, add. 2 times 3, multiply. Negative 4 plus 6, add. 2 times 2, 4. Negative 4 plus 4 is 0. Perfect. We got it. So we have f of x equals our original factor that gave us that 0, x minus 1. Our new factor is 2, so that must come from x minus 2. And our remaining polynomial to be factored, these are the remainders, so that's constant, so that's x squared plus 3x plus 2. Now we just have to break down x squared plus 3x plus 2. So on the side here we'll do some side work. X squared plus 3x plus 2. I'm trying to multiply to 2. When it adds to 3. If you don't know how this is working, try watching the video on factoring using Bergman technique, which teaches you how to do this. What multiplies to 2 and adds to 3? It's easy. The numbers are 2 and 1. So we can go back to our original equation and say, so f of x equals x minus 1, x minus 2, and I've shown my work here, so I can break this quadratic down into what Bergman technique told me is x plus 2, that's from this number, and x plus 1, that's from this number. So that's factoring. We factored this quartic polynomial, and the terms were missing, no problem, we handled it fine. But we haven't solved yet. So what does solving mean? Solving means We want to set f at x equals 0 to find the zeros. You don't have to write this when you solve a question. It's just for learning purposes I'm writing it down. In other words, we want to solve where does this equation equal 0. Where that equation equals 0 will be the x-intercepts, or the zeros. So we just set the equation equal to 0, and now we're going to solve each piece individually, which is a piece of cake. We're just saying if this whole equation equals 0, then either or x minus 1 equals 0, and or x minus 2 equals 0, and or x plus 2 equals 0, and or x plus 1 equals 0. And now solve each of them individually. Get this negative 1 to the other side just by adding 1 both sides, and you get x equals 1. Add 2 both sides here, and you get x equals 2. Subtract 2 both sides here, and you get x equals minus 2. And then finally, subtract 1 both sides here, and you get x equals minus 1. And those are your 4 answers. You put little boxes around them so marker can easily find them. X equals 1, x equals 2, x equals negative 2, and x equals negative 1. And by the way, we know that x equals 1 is a solution because we tried it already and it gave us a 0. And we know x equals 2 works as well because we got a 0 from it. It means we know from factor theorem or remainder theorem if this equals 0, that was one of the zeros. We can also check though, just to check our solution, how do we know negative 2 works? We could try x equals negative 2, and we'll see we get, back in the original equation, negative 2 to the power of 4, better put that in brackets, minus 5 times negative 2 squared plus 4, which gives us 16 minus 5 times 4 plus 4. So we get 16 minus 20 plus 4, and sure enough, 16 minus 20 is negative 4 plus 4 equals 0. You could check the other one too if you had time on a test. But clearly, all these numbers, negative 2, 2, 1, probably negative 1 as well, you can sub it in, check on your own, are all zeros. So what we've done is we factored this quartic polynomial, even though their terms were missing, and then when we were done factoring, we solved for each individual brackets to find each zero.